What up, everybody? Welcome to another episode of Let's Ask Paul, the podcast where you can ask me electrical questions by simply going to paulabernathy.com. That's a free portal sponsored by Wix that allows you to be able to submit questions to me, and I will answer your questions either in an email or, if selected, on a podcast, much like today's podcast. So, let's kind of get started. Oh, before I do that, I have to tell you, if you haven't checked it out yet, please go check out fasttrackstube.com. That's our video delivery platform. We have a lot of videos over there. There's a new code change series by Ryan over there for the 2023. There's a bunch of other videos, some of my calculation videos. A derating demystified is there. The 2.0 version. 3.0 is coming out soon. Don't worry. Yeah, all of that's over there at fasttrackstube.com. And if you're looking for electrical exam prep courses or you want to get residential, commercial, and grounding and bonding, you just want to get deeper into the code, then we have great courses over at fasttracksystem.com as well. So make sure you check that out. All right, let's get into today's question that was asked and sent to us through the portal, and we'll address this one first. Right, it says, hello, Paul. I recently passed my electrical inspector exam, but I'm not super knowledgeable in the subject. I am a structural guy, but have taken an interest in the other trades. On one of the recent TikTok videos about the cable coming into the panel, and I'm assuming that's the one that causes a bunch of controversy from people who clearly don't understand the National Electrical Code, but that was the 312.5C controversy, I guess. That's what he's talking about. Anyway, he says, coming into the panel, it mentioned that there were only 2 cables or 3 with their butterfly fitting. In my area, I saw about a 3/4 KO with 4 14.2s coming through. Is it regulated by the NEC or the manufacturer's spec on the panel itself? Thanks for the help. I love your vids. So helpful to someone like me. Okay, well, thank you for the question. And so let me address this here. And for those that aren't aware, we have been posting some questions and graphics and stuff over on our TikTok channel. If you were looking for it, it's the @ Fast Track System. But I'm sure you could search for Master the NEC and you'll see it. We have a lot of questions are posted over there, and then I'll give comments, and then sometimes I'll even give a video comment to one of my videos explaining the calculation or the question or something like that. But we like to leave them running a little bit so we can see people's responses, because it might shock people that they really don't know what they think they know. So knowledge is king. So whatever gives some extra knowledge, check it out. If you're not a TikToker, I am not a big TikToker. Darlene manages that for me, but again, there's some good content over there if you're interested in that type of thing. We just kind of started it not too long ago, so it's not a big thing for us. But hey, check it out if you're into TikTok. All right, so the question. All right, so you have a 3/4 KO opening. And by the way, KOs can only be done by manufacturers, right? Whether they're concentric or eccentric. When we take a panel and we punch our own holes, that's literally just making your own hole. They're not governed under the same rules as a KO, because that's something that, depending on the rating of the enclosure, whether it's a NEMA 1, which is like an indoor panel, or cabinet, or something like a NEMA 3R, then that is something that gets evaluated very differently. And then the KOs get evaluated as part of that. Now, adding an additional hole to be able to bring a cable through, you can't just make a hole and leave it open. Obviously, we would have to, close that. But you're allowed to make holes, and every manufacturer may say something differently when it comes to that, because we do have to worry about conductor deflection, 312.6. And again, using common sense in how you approach it is going to be the flavor of the day. But again, consult your manufacturer if you're going to add additional holes into a panel, and make sure you're not going to add any that you don't intend to put a connector in it or something like that, or a raceway too. You're not just cutting a hole and leaving it, okay? All right, so let's talk about this. So who addresses it? Well, the National Electrical Code basically says 110.3b, you have to follow the manufacturer's instructions. So they're not going to specifically address the clamp. Now, clamps from the manufacturers of those clamps, it's like a Bridgeport or an ABB or Appleton or whatever. They're going to give you instructions about how many cables can go in it and this type of thing. It's kind of like wire nuts, believe it or not. It's going to tell you this size wire nut, how many conductors you can actually put in it, and the manufacturer is going to give you that direction, whether you follow it or not. It's pretty evident that people don't always follow the rules, but they're going to give you that direction, and that's who you follow. They're the manufacturer. And I often tell people when you're working with electrical equipment, and we get a lot of questions, I get a lot of questions where people send in stuff about certain things for different manufacturers. And the real answer to that should always be, you really need to reach out to the manufacturer. And it's not going to be any different than reaching out to me. Now, if it's code specific, that's great. But if it's something specific to a manufacturer's product, can you use it for this or that? And you really need to reach out to that manufacturer. And today, all manufacturers have really good customer support feature, whether it's a live chat or whatever. Now, be careful. Sometimes you talk to a sales engineer that really is not connected with the people that would be codes and standard driven. So sometimes you'll get the generic responses, but you got to dig a little deeper. But you can get to who you need to get to and find out. So in this case, if the connector is actually evaluated to hold 4 14.2s, for example, then that would be okay. Now, as an inspector, when you see somebody bringing a bunch of cables through a connector, the question that you can ask yourself if this looks excessive is, as an inspector, you can say, can you show me where it says that connector can handle that many cables? That's not unreasonable. Now, the electricians hate it, right? The reality is, if you can squeeze it in there, they might squeeze it in there. But as a municipal inspector for years and training municipal inspectors, I tell municipal guys and gals, don't be afraid to ask. Because it's very easy today to get literature on just about anything on the internet. So you can go right to that manufacturer, and they should have literature that says the maximum number that can be through that connector, right? For example, an SE connector, whether it's SEU style or SER, which are different connectors, by the way, they will tell you that that's for use with SEU or SER. It's not for use with jamming a bunch of non-metallic sheath cables through it. Makes sense? So again, it's not going to be so much an NEC thing other than 110.3b, which is telling you to use it in accordance with the manufacturer's instructions. But it really means that you have to communicate with the manufacturer to do that. It's also not unrealistic for an inspector to say, let me see the packaging, because it's probably not going to be on the clamp. So they might say, let me see the packaging, let me see the clamp, let me see the box, because typically that's where your information will be posted on the box. Especially the smaller the clamps, more apt to find the information about it actually over on the box that they came in, things like that. Okay, so it's not going to be so much an NEC thing, except for the NEC reminds you that, for example, with all the wiring methods, the connectors and clamps ought to be listed. Okay, .6 listing under the various types of wiring methods in Chapter 3. But then, of course, the manufacturers have their own listing and information on what this clamp is or this connector is designed to do and how much it's going to hold. Okay, so don't be afraid to reach out and make people show you this, even though it might irritate them. You have every right to do that as the AHJ. Now, don't make up stuff. Okay, don't just kind of wing it. Make sure you're working from something, and if you don't know, they need to provide it for you. Okay. All right. Hopefully that answered that question for you the best I can answer it. Let's see if we got some more here. Okay. Next question we have is, Paul, do you know when it became more common to pull an EGC, as equipment grounding conductor, instead of using the metallic conduit as a main EGC for feeders and branch circuits? I have been doing research on this topic, but cannot seem to find where the practice changed. Thank you. Your podcast has helped me very much over the last 5 years. All right. Well, thank you again for submitting. Took you 5 years to submit a question, man. What took you so long? But thanks for listening to the podcast and hopefully sharing it with other people on the job site and letting everybody know. Again, folks, I'm going to remind you, we do not pay for advertising. We really appreciate the word of mouth and you folks going out of your way to actually be our little warriors for code. And when you're on a job site, you see somebody say, hey, have you listened to that podcast? Go search for Master the NEC podcast on all of their favorite podcast listening platforms. Or how about you just get our mobile app, which is free, by the way. Just go to necchat.com from your phone, and you can download it directly onto your phone. Just accept it. And that's a great way to be able to listen to our podcast and share it with somebody. Let them know how easy it is to do it. Anyway, so good question. So I can tell you that engineers love to have a wire type equipment grounding conductor in there. Even though in many cases in 250.118, you have a list of what can be an equipment grounding conductor. And obviously EMT is a tubing that qualifies as an equipment ground, rigid metal conduit, intermediate metal conduit. All of those qualify as an equipment grounding conductor. And you don't have to size anything. I mean, it's just the Raceway, which is, again, the big push from the Raceway industry. They're like, hey, don't worry about the wire type when you can just, the Raceway is fine. For many people, the problem, and I can't pinpoint history, I'm going to say obviously sometime in the 80s when there was a project called the Jimmy Project that took place at Georgia Tech, I believe. And it's actually, the whole story is in our grounding and bonding course. And it's been so long since it, and you're out of sight, out of mind. I don't remember all the details, but a lot of testing was done to validate the Raceway as being, obviously effective for clearing an overcurrent protective device and kind of justifying that through the years. And then trying to compare it to the wire type. Wire is a bit more direct, right? You connect it from point A to point B, and you're relying on that and the known values of resistance that's in a copper conductor or an aluminum conductor. We can see the general values in Chapter 9, Table 8, based on that temperature condition. But in reality, that's what's, sometimes people just feel that's a little more reliable. Whereas with the Raceway, you've got to worry about the couplings being done right, especially if the EMT and it's maybe set screw. And what I can tell you is in a fault condition, even if they're loose, they're probably going to arc over and still clear an overcurrent. But I say probably because, again, I'm not into any testing. That's what the Jimmy Project was all about. But a lot of people just feel more comfortable with including the wire type. Interesting enough, there are not very many engineers that I'm aware of today that designs electrical systems where, obviously if it's PVC, no brainer, got to have a wire type in there, right? But when it's a metal Raceway, like an EMT or rigid or intermediate or something like that, they're probably feeling more comfortable just putting a wire type in there. Now, pinpointing the exact time, and I think I followed up with you, the submitter, on this with some data. I gave you some reports that you can read and all that kind of stuff, which I won't reference here because I'm kind of just talking about the question. But it actually shows some history. But I'm going to say somewhere there was a changeover where people said, and look, rigid and intermediate and all that have been around for a long time. Even back when, we had non-metallic sheet cable that didn't have equipment grounding conductors in it or undersized, equipment grounds in it. So there was a period where enlightenment became the issue where people said, you know what, I want more of a direct connection. And that's where the wire type started getting put in the Raceways and everything like that. So I'm not that much of a historian. What I can tell you is it's obviously in the 70s or 80s where people started changing, really serious about it. But I'm sure there's a historian that knows the history of that. I'm just not into that. I don't care to know the history of it. I just know what's required, and that's what we do. But those out there may be able to connect with somebody. But I did send you some information that you can research it yourself. But, Even it's important to understand that even if you had a metal raceway in the engineer design for the equipment ground, people tend to think, well, then since you could use the raceway, does the equipment ground of the wire type that's inside of it, can it be less than what this required by 251.22? And the answer to that is no. It's still got to be properly sized. So you might think it's in addition, but if you're going to use it, it still needs to be properly sized. And again, that's based on the size of the overcurrent protective device. Okay, so we have to follow all the rules in 250.122, regardless if you design a metal raceway and you put the wire type equipment ground in there and you think, well, I'm going to use the raceway, I can make the wire type smaller, and that's not the case. That would still need to be properly sized. Okay. All right. So hopefully that answers that question for you. Good question. I wish I could give you a little more history than that, but I can't. So don't be a stranger for another 5 years. Make sure you submit more questions, and I will do my best to try to answer those for you. All right, let's see what else we got. Okay, next question we have. Hey, Paul, I had someone recently ask me about what code reference talks about if a dishwasher has to be on a dedicated circuit. I'm having trouble finding that particular code. I'm using the 2023 code book. Okay, great question that was submitted. Now, first of all, there's the only thing that's going to require, other than the loading, right? So we have to look at the loading rules in the code, but or permissible loads. But let's talk about the dishwasher first. If the instructions that come with the dishwasher, which very few people actually read, if it requires an individual branch circuit to that actual dishwasher, then that's the rule. Okay, that's the manufacturer's instructions. That's what they want. They've done their loading. They've done their testing. That's what they want. So you follow what the manufacturer wants, and you run that. If it's a 20 amp branch circuit, then and if that's what it is, that's what they call for. That's what you're going to run, and that's it. That's the only thing that's going to be on that circuit. Now, if they don't kind of tell you that, then it ends up being something that falls into a permissible load type of thing. What's a load can be on it. Now, if this is a cord and plug versus a direct hardwire dishwasher, then it can be kind of different because you have fixed appliances in place. And again, if this is being installed, and we're going to use an example of running a 20 amp circuit for a receptacle underneath the sink area. Let's say one receptacle is going to be used for the garbage disposer, and one's going to be used for the dishwasher. So the question is, can you do that type of scenario? And so we're gonna address it that way. But I want to do the first part of this is dedicated circuit. So very clear. If the manufacturer's instructions tell you that it needs to be an individual branch circuit run to the dishwasher, then that's what you're going to do. Okay. All right. So let's assume at this point that is not the statement that is being made by the manufacturer of the dishwasher. Okay. And you're the electrician, and you're going to be running. You have two choices. You could run let's say you were to run a 12-3 over. You have a red and a black. You break the tab, share the neutral, and you've got two. You got a multi-wire branch circuit over there, and you're going to run it something that way. Okay. You have those options. Right? Assuming both of these are 120 volt loads, and there's an option there. Or you can say, well, can I run a 12-2 there, and can I supply both of these loads and buy that one duplex receptacle and only run one 12-2 over there? Okay. Again, manufacturers didn't say that it needed to be an individual branch circuit at that point. Okay, so that's what we're going to look at, and we're going to look at permissible loads, and we're going to kind of give you an idea of what we're talking about here, and we'll talk about all the scenarios that are involved in it. Okay, so for those that do have your code books, right? For those that are following along in their code book, that's the first thing we want to kind of look at. Let's address the devices. Okay, first in 210.21. Now, in our case, we're gonna do a cord and plug first. And we're going to put a duplex receptacle under the sink, okay? And what we're going to do is we're going to be supplying the top part will plug in for the dishwasher, and the bottom part will plug in for the garbage disposer. So both of these are cord and plug, although they are fixed in place, right? But they are cord and plug connected. So the first thing that we want to look at is, obviously, this is 2 or more receptacles. Okay, it's a duplex. It's 2 receptacles mounted on a single yoke. So what we're looking at first, we want to focus on the outlets and the devices that are going in there. So we're going to look at 210.21, and I want to bring you to B2 because that is total cord and plug connected loads. So we'll address this first. It says total cord and plug connected loads. It says we're connected to a branch circuit supplying 2 or more receptacles, and again, that's what a duplex is, or outlets. A receptacle shall not supply a total cord and plug connected load in excess of the maximum specified in table 210.21b2. Now, if you look at that table, and we're talking a 20 amp rated receptacle, duplex is what we're running for this. And as you can see, the circuit's rated 20, the receptacle's rated 20, but the maximum load in amperes is 16. Now, this is interesting because we're not talking about the entire duplex. Either one of those receptacles, the top one or the bottom one, the maximum load for that cord and plug load can exceed 16 amps. Now, it's important to realize that I could put 16 amps on the top one and 16 amps on the bottom one, right? They're 2 separate receptacles, okay? Now, you and I both know that the overcurrent protective device is not going to allow 16 amps to be pulled on the top and 16 amps to be pulled on the bottom when it comes to what the device or the overcurrent device is going to operate at. I mean, all we're saying here is loading. So if one's not being run and the other one's being run, so the dishwasher's not on, but the garbage disposal is on, right? Then either one of those cord and plug connected loads has to have a maximum load not more than 16 amps on either the top or the bottom, okay? That type of thing. But you could have 16 on both. It's just realize that the overcurrent protective device is not going to allow that to happen anyway. So it's kind of moot. We're just talking about the receptacle and what loads can be placed on it, okay? The maximum load, right? Does that make sense? Hopefully that makes sense. Okay, so we addressed that. And so then we go down and look, okay, well, what is the rating of the receptacles? What can we have? So 210.21b3 just reminds us that it's a 20 amp rated circuit, that the receptacle can be a 15 or a 20 amp rated receptacle in amperes. In this case, we're keeping it simple. It's a 20 amp rated circuit. It's a 20 amp rated duplex receptacle. Okay, so keeping it simple for our sake right here. Okay, but could you put a 15? Absolutely. Okay, all right. Now, the problem with that is if it is a 15, then you got to come back to this cord and plug. And if the rating is 15, then the maximum load is 12. Okay. And this, again, is all about the receptacle device that is in question. So let's not get it confused. Now, I can hear people out there already confused. So let me summarize because, again, sometimes people can't follow these things through. We're just talking about the receptacle and the maximum load that you could put on the receptacle. If it's a 20 amp rated receptacle, the top and the bottom, which is 2 separate receptacles, if it's a 20 amp circuit and a 20 amp rated device, then the maximum load that could be pulled on either one of those receptacles is 16 amperes. Okay? And that comes from table 210.21b2. If we happen to use the allowance that's in table 210.21b3 and we put a 15 amp rated device in there, right? Then that's a 20 amp circuit. Then we still have to remember that since the device is now being dropped down to a 15 amp rated receptacle, now the maximum load that could be pulled on each one of those receptacles is 12 amps. You with me? But it's totally moot in our condition because we're using a 20 amp device and a 20 amp branch circuit. Okay? We're talking about running to a garbage disposer or an in-sink waste disposer and a dishwasher. You with me? Okay. I always feel like I have to clarify that because there's somebody that posts in the comments that they couldn't follow my logic or I was too confusing. I'm sorry. Code is confusing. And it is a podcast, so that's why I'm redundant, so that I can make sure that everybody walks away here understanding. Okay. So the next thing we know, so we're clear. We're perfectly okay. We're going to select a garbage disposer and a dishwasher that when they're plugged into either one of these receptacles, the nameplate's going to show that they're not going to be pulling more than 16 amps on either one. So at least we're that far. Okay, so we're compliant with that. We're compliant with the receptacle and everything so far. Now, the next thing that we want to look at is 210.23. Now, 210.23 is permissible loads on the multiple outlet branch circuits. So I'm going to remind you that, again, that two receptacles mounted on a single yoke is still two or more, receptacles. It's two receptacles on one yoke. So that's the one concept that we have to emblazon in the brain when we look at a receptacle, a duplex, that is actually two separate receptacles mounted on one single yoke, right? Okay. So let's kind of get into that mentality mode now. So next thing we're going to do is we're going to jump, and I'm in the 2023, by the way, so there's kind of a new structure here for those that are saying, what the hell are you talking about? It is kind of a new structure here. And so 210.23, we're looking at B, and that is 15 and 20 amp branch circuits, okay? That's what we're looking at. And so what we're going to look at here is it says, and I'm going to read this to you because no need for you. You're probably driving in your car, rolling down the road. I'm going to read you what it says here, okay? It says 15 and 20 amp branch circuits. It says a 15 or 20 amp branch circuit shall be permitted to supply lighting outlets, lighting units, or other utilization equipment, or any combination of them, and shall comply with 210.23 B1 and B2. Okay. Now, again, that's our general statement. So we have a B1 and a B2. All right. So let's look at B1 because I'm going to tell you right now, if it's a 20 amp circuit, I want to be able to get 20 amps out of it. Okay. I'm paying for it. I'm paying for a 20 amp breaker. I'm paying for a wire that can handle 20 amps. I want to be able to get that out. So let's look and see what it says here. All right, so cord and plug connected equipment that is not fastened in place. Okay, we're going to skip that. Why? In our question. Because the dishwasher is screwed in place. It's got two little screws at the top. When you put it back in, you screw it up into the cabinet. And a garbage disposer is mounted onto the bottom of the sink in the bracket you put on, so it's fastened in place. So we're skipping it. Even whether it's applicable or not, it doesn't matter. We're skipping it. The next one says to utilization equipment fastened in place. So that's item number 2. So if you're in the 2023 edition of the NEC, it's 210.23 B2. It says the total rating of utilization equipment fastened in place other than luminaires shall not exceed 50% of the branch circuit ampere rating. Now listen, where lighting units, cord and plug connected utilization equipment not fastened in place, or both are also supplied. Did you hear that? So in our case, it's not applicable because we're not dealing with cord and plug connected equipment that's not fastened in place because ours is fastened in place. And we're not dealing with any lighting units. Make sense? So we ignore all that. And I think that's where a lot of people get lost in that, right? Is they think that you start getting into these permissible loads. And that's the whole reason I wanted to go there, because we're talking about an application for a garbage disposal and a dishwasher. They are fastened in place. Now, that's why it's so important to know that this requirement does not apply to branch circuits that supply only fastened in place utilization equipment. And the example that is given in Link, and let me give a shout out to NFPA Link, because a lot of people are asking me on social media, what app are you using for the code? And it's just Link. It's an annual subscription from NFPA. It's worth every penny. It's about $150 to get a subscription, and you get access to all of the NFPA documents, whether it's 70E or 72 or whatever. It's well worth the money. And it's, again, if you're an electrical contractor or electrician out there, you should have a link on your phone. And you can use it everywhere, on your mobile device, tablets, desktop. One account, use it everywhere. And they give an example in the commentary, which kind of hammers home right here. It says the requirement does not apply to the branch circuit that supplies only fastened in place utilization equipment. For example, on a 20 amp, check it out, folks. On a 20 amp branch circuit that supplies a waste disposer and a dishwasher, neither appliance is restricted to 50%. That would be 10 amps, okay, of that 20 amp circuit. Restricting it to 50% would be 10 amps. Neither one of them are restricted to that of the branch circuit rating. The combined load of the two appliances cannot exceed 20 amperes, obviously, because it's a 20 amp rated branch circuit. But if one's pulling 12 amps, right, and the other one's pulling 8 amps, that's 20 amps. Those are not continuous loads. They're not going to be on 3 hours or more, right? It's just, who does that? So I'm going to get my money's worth. It's a 20 amp circuit. So can I run a 12-2 to a receptacle underneath the sink? And can I, and don't forget that it's still going to be on GFCI because it is for the dishwasher. You're plugging that into it. We all know that, so I don't need to go there. Somebody's going to say that in the comments. But again, I can't cover everything in a freaking podcast, folks. Chill out. So the combined loads can't exceed 20 amps because that's the rating of the circuit. Then that's fine. And remember, the receptacle ratings means that whatever I plug into the top or the bottom, that maximum load can't exceed 16 amps. It's a 20 amp circuit. But that applies individually to the top receptacle and to the bottom. So you just have to make sure that your cord and plugged, fastened in place utilization equipment is not going to exceed 16 amps. And most dishwashers won't, residential style, and most garbage disposers won't either. So you're perfectly fine. So can I run that 12-2 there? Absolutely, I can do it. Not a problem. All right. So hopefully that answered your question on that and gave you something to think about. Now, if you want to run the multi-wire branch circuit and run a 12-3, it makes you feel better. Then you can go in there, break the tab, share the neutral, have the top run the dishwasher and the bottom run the disposer. Then you do you, boo. That's perfectly up to you if you want to do that. But again, I just showed you what the code says and the fact that you don't need to do that. Okay. All right, folks. Hopefully you got something out of today's episode. Thanks for listening. And remember, if you've got any questions you want me to answer on a podcast so you can chill out down the road or on the job site, put it on your headphones and listen to me rattle away. Remember, we have over 800 plus episodes available. All you got to do is go to your favorite listening platform and search for Master the NEC podcast, and you will get all of our episodes, or you can go get our free mobile app from our website, fasttracksystem.com, or you can go to our sponsored portal, www.necchat.com, and download our mobile app, put it on your phone, add it to your screen. You're not going to put the app on your phone. All you're doing is adding a link on your screen to get to this PWA, which is Progressive Web App. And it's not going to take up any storage in your phone. And make sure you accept notifications in case we run specials or some special announcement or something we want to send out to you. We promise we won't spam you. We won't bug you. But again, that's how you stay connected. And our app has so many free resources on it. Okay. All right. That's all I got, folks. Till next time, stay safe. God bless. Hope you got something out of this episode of Let's Ask Paul.